Hello, welcome to the Koios tuition channel and the factorization video. In this video we will go through 7 examples on factorization. First, we will start with 3 simple questions where we only have to look for a common factor to answer the questions. Then we will cover a method for factorizing simple quadratic expressions. And finally we will move to more complex quadratic expressions where the x squared term has a coefficient. So, let's get on with it. Before I start on example 1, I'm just going to briefly talk about what factorization is. So factorizing is the opposite of expanding brackets, and the goal is to simplify an expression by writing all the common factors just once. So what happens is you end up with brackets to distribute the common factors by all the other terms inside the bracket. And I will come back to that explanation at the end of this example. So let's start on example 1. We have 5p plus 15. And so in this expression you see that we have 5 multiplied by p and 15. And we can break these two terms down into the factors. So 5p can be thought of as 5 loads of p's, 5 multiplied by p, in the same way that 15 can be thought of as 5 multiplied by 3. And what you see is that both of these terms have a common factor of 5. Both of these terms have a 5 as one of the factors, so that's what we will factorize out. Instead of having 5 times p and 5 times 3, we want to have 5 multiplied by both p and 3 at the same time. And of course you don't have to write the multiply sign, and so the answer is 5 open bracket p plus 3. And now I'm just going to quickly explain what I meant by distribute the common factor. 5 was the common factor of 5p and 15, and what we've done is we've written it once, but it's still multiplied by both of those terms, by the first and the second term in the expression. And what you want to do is you want to check your answer at the end, and the way to check that is to expand, because factorizing and expanding are the opposites of each other. So 5 times p is 5p, 5 times 3 is 15. And you see that we ended up with the same thing we started with up here, and so provided we didn't make 2 mistakes, we cancel each other out in this working out and this working out, this here 5 open bracket p plus 3 should be the answer. And let's start on example 2. It says factorize fully this expression, and I will come back to what fully means in a second. Let's just write down the question: 4x squared plus 2x. When you're starting with factorizing, it's a good idea to break down each term into every single one of the factors, and with numbers what you want to do is break them down into prime factors so that you know you have every single possible factor written down. So 4x squared can be written down as 2 times 2 times x times x, and 2x can be written as 2 times x. And what we see is that we have 2 common factors. The 2 and the 2 is a factor of both terms, and the x and this x is a common factor in both of those. So what we will do is we'll take those 2 outside the bracket. So we will have 2 times x multiplied by, and inside the bracket, once we've taken out this 2 and this 2 out here, this x and this x out here, what we left in the left hand term is 2 times x, and what we're left with the right hand term is, and it looks like nothing because we've taken out the 2 and the x, it looks like we're not left with anything, but we still need to write something down, which in this case is 1, because 1 multiplied by 2x gives us 2x when we expand. If we wrote 0 here, 0 times 2x would disappear, would give us nothing, and this term would disappear, and that would give us the wrong answer. And as a final step, you rewrite this simplified without the multiplication signs. So we have 2x, open bracket, 2x plus 1. The answer is 2x, open bracket, 2x plus 1. Now, what the question told you in Factorize Fully is that there will be more than one factor you can take out. And I'm going to do this question again, slightly differently. If I write it down, 4x squared plus 2x. So let's say you were doing this question and you realize that you can take out an x. So you factorize an x out and you end up with this, 4x plus 2. And you think that might be the answer, but it's not, because there is still a common factor between these two terms here inside the bracket. And we noticed that common factor here. We had 2 and x as common factors, 2 and x as common factors. In here we've only taken out an x. So we need to take out another common factor of these two terms here, which in both cases is 2. 2 times 2 and 2. So what we will do is x and then 2. 2x plus 1. Now that we've done that, we can simplify this. We multiply the x by the 2 to get 2x, and 2x plus 1 in the bracket. So the answer again is 2x open bracket, 2x plus 1. So from both of these working out, you see that whether you take out all of the common factors in one go, or if you take them out one by one, step by step, you should end up with the same answer. So if I now come back to this answer on the left, what you'll want to do when you're finished with the question is to expand out again, just to make sure you have the right answer. So what is 2x multiplied by 2x? 2 times 2 is 4. X times x is x squared. What is 2x multiplied by 1? 2x. And you see that we have here, when we've expanded, we've ended up with the same expression as we started with before we factorized. So it looks like we have the correct answer here. Okay, and now moving on to example 3. The question again tells us to factorize fully this expression. This fully gives us a hint that we will have to take out more than just one factor out of each of those. So the question is 7x squared y minus xy squared plus 14xy. What I'm going to do is I'm going to rewrite this expression and break down each term into its factors. So 7 is a prime number, so I can't factorize that anymore. I can't break this down into any other two factors. 7 multiplied by x multiplied by x multiplied by y. X times x comes from x squared, the y comes from the y. Minus x times y times y. The x stays as x. Y squared breaks down into y times y. Finally, we have 14 here, which breaks down into 7 times 2 multiplied by x multiplied by y. When you get more confident with factorizing, you won't have to break down each term into its prime factors, but I will do it this time just so we're confident that we have every single possible factor that we can take out. So let's have a look. Let's look at the first factor, 7. 7 appears here, doesn't appear in this term, and does appear in this term, so we can't factorize it out of all three terms. X appears in the left hand, the middle, and the right hand expression. The terms. So it is a common factor of all three terms. We have another x here. We don't have another x here. We don't have another x here. So this second x is not common to all three terms. And finally y. We have the y here, we have the y here, and we have the y here. So y is a second common factor. So we will take out x times y, and what are we left with? The left hand term, we had 7 times x times y, but once we've removed the common factors from the term, we're left with 7 and x. 7 times x. The middle term, we've removed the x and the y outside the bracket, and we're left with the y. But this term is negative, so we're left with negative y. Finally, the third term, 7 times 2 times x times y, but this x and this y have been moved to the outside of the bracket, so we're left with 7 times 2. And last step, simplify, so get rid of the multiply signs where we don't need them. We have xy, open bracket, 7x minus y plus 14. So the answer is xy, open bracket, 7x minus y plus 14. Okay, moving to example 4, we have to factorize x squared minus x minus 6. And it's tempting to try and take out an x out of these expressions, but what you need to remember is that if you're asked to factorize a quadratic expression in the form ax squared plus bx plus c, is that you'll have to use a different method of factorization than just looking for common factors in all three terms. I'm going to go through the simpler method first, and then I'm going to show you the more complicated method, the longer method that will be used for more complicated quadratic questions. So, starting with this, x squared minus x minus 6. First thing you'll do is you'll write the last term, this minus 6 here. If I use a different color actually. What you'll want to do is take this last term minus 6 and write it out on the side here. And then you will find all the possible factors of minus 6. So which two numbers do we multiply to make minus 6? It's minus 1 times 6 or 1 times minus 6. It's also 2 multiplied by minus 3 and minus 2 multiplied by 3. And those are the only factors of minus 6. And now we're going to look for a pair of these factors. We're going to look for one of these pairs of factors which adds up to give us the coefficient of x. Now, there doesn't seem to be a coefficient of x, but it's a negative x. There is one of those negative x's, so the coefficient is actually minus 1. So we're looking for minus 1. Which pairs adds up to give us minus 1? Minus 1 plus 6 gives us plus 5. 1 and minus 6 gives us minus 5. 2 and minus 3 gives us minus 1. Minus 2 and 3 gives us plus 1. So we see that it's 2 and minus 3 that add up to give us the coefficient of the middle term of the x. So the last step is to write out two brackets and to put these numbers, these factors of minus 6, inside the bracket. So this is a positive 2, so we write positive 2. This is negative 3, so in the other bracket we write negative 3. The answer is x plus 2 in one bracket, x minus 3 in the other bracket. And of course we can check the answer by expanding it. Expanding is the opposite of factorizing, so if we expand this we should end up with x squared minus x minus 6. So x times x is x squared, x times minus 3 is minus 3x, plus 2 multiplied by x is plus 2x, 2 multiplied by minus 3 is minus 6. Last step is to simplify these two terms. X squared minus 3x plus 2x gives me minus x, and then a minus 6. So we see that this is the same as the question that we factorized into the two brackets, so that gives me confidence that this is the right answer. Okay, and example 5. We have to factorize x squared minus 4. Now, there are no common terms that we see between the x squared and the minus 4, and it doesn't look like the standard quadratic. If we compare it to the standard quadratic equation, which is a x squared plus bx plus c, what we notice is that we have the x squared term, we have this one, and the minus 4 is the constant term at the end, but the bx term is not here. It's invisible, or what it means is that there are 0 of them, 0 x's. So we can actually rewrite this expression as x squared plus 0x minus 4. And now it does look like a normal quadratic that we know how to factorize. So what we're going to do is we're going to use the exact same method we did in example 4. So the first thing we do is we look at the last term, the constant term, minus 4, write that on the side, and we try to find pair of factors which multiply to give us minus 4. Those are minus 1 and plus 4, plus 1 and minus 4, minus 2 and plus 2, plus 2 and minus 2. So these are all the pairs of factors which multiply to give us minus 4. What we need to do is we need to find which pair adds up to give us this coefficient here, which is plus 0, or just 0. So we're looking for a 0. Minus 1 plus 4 gives us plus 3. Plus 1 and minus 4 gives us minus 3. Minus 2 and plus 2 gives us 0. Plus 2 and minus 2 gives us 0. So we see that it's either this pair of factors or this pair of factors that we want. Now, what you'll notice is that this is exactly the same. Minus 2 times plus 2 and plus 2 times minus 2 is the same. These are the same pairs of factors, they're just flipped around. So it doesn't matter which one of these we choose. So the final step is to write two brackets with x's in them, x, and to write these two factors in them, x minus 2, x plus 2. So the answer is x minus 2 in one bracket, x plus 2 in the other. Of course, we can always check if that's correct. And the opposite of factorizing is expanding, so we check by expanding this. X times x gives us x squared, x times plus 2 gives us plus 2x, minus 2 times x gives us minus 2x, and minus 2 times plus 2 gives us minus 4. Last step is to simplify these two terms. Positive 2x and negative 2x cancels out. That gives us 0x, or nothing, so we don't write anything, and the minus 4 from the end. We see that that's exactly the same as the question expression. So we're confident that this is the correct answer. And now we've gotten onto a more complicated quadratic factorization. Why it's more complicated? It's because there is a coefficient of x squared. There is some number multiplied by x squared. And what that means is we'll have to employ a slightly more difficult method. It's not that much more difficult, it's just longer to work out. And so with more steps there's more chance of making a small mistake. And you'll just have to learn the method. You're just going to have to practice enough of these questions to memorize the method. So, what we do, write down the question, 2x squared plus 7x plus 3. The first thing you will do is you will multiply the first and the last number together. You're going to multiply the coefficient of x squared and the number without any x's together. So, positive 2 multiplied by positive 3 gives me a positive 6. So this positive 6 up here is the number that we write on the side to try and make coefficients. To try and to come up with different factors of this number. Positive 6. How can I multiply two numbers together to get a positive 6? It's 1 and 6. Minus 1 and minus 6, 2 and 3, minus 2 and minus 3. And those are the only factors of 6. So what we will do now is we're going to add these factors up to try and see which of these pairs of factors adds up to give us the middle coefficient, just plus 7. So we're looking for plus 7. 1 plus 6 is 7, minus 1 plus minus 6 gives me minus 7, 2 plus 3 gives me plus 6, sorry, no it doesn't, plus 5, minus 2 plus minus 3 gives me minus 5. So we see that it's the first pair of factors that I need to use. So, what we're going to do is we're going to take, and if I use blue color now, we're going to take this middle term plus 7x and we're going to split it into these two coefficients, 1 and 6. So what we'll end up is plus 1x and plus 6x. Okay, so do you see that 7x I'm going to break down into two terms, plus 1x and plus 6x. But together, if I was to simplify these two terms, I would go back and end up with a 7x. So now that I've done that, I copy the rest of the question around it. 2x squared and plus 6. So, can you see that I haven't changed the value of this expression? I've just changed the way it looks by breaking down, by unsimplifying the term in the middle. So what we do now is we consider the two left-hand terms by themselves and the two right-hand terms alone. So we consider these two terms separately from these two terms. So we look at these two terms and we see what is a common factor. What can I factorize out of these two terms? This has 2x squared and this has plus 1x. We see that the only common factor of these two terms is x. So we take out x outside of a bracket. And we end up with x, 2x plus 1. And we do the same thing for the right hand half of the expression up here. So what's a common term of 6x and 3? And the common factor of 6x and 3 is 3. And we're left with 2x plus 1. Now at this stage, in the working out, you should end up with the same expression inside the bracket here and here. If you haven't, you either need to factorize something else out of either of those brackets, or you've made a mistake up here. But if you've arrived at this point and you have the exact same expression in the left hand bracket and the right hand bracket, you're good to go. So we'll continue working through this. So what you now see is that the left hand term has x multiplied by this whole expression, and on the right hand side we have 3 multiplied by this whole expression. So what you see is that this 2x plus 1 in the bracket is a factor of both the left hand term and the right hand term. So we can take it outside of the bracket, and the bracket being here and here. So what we'll do is we'll write 2x plus 1 multiplied by whatever's left over from this term and this term. So x multiplied by this whole bracket. If we take out the whole bracket outside, we're left with just x. So we have, let's use black, we have x. With the right hand term, we had 3 multiplied by the bracket. If we take out the bracket out here, outside of the big brackets, we're left with just plus 3. So you see that the answer is 2x plus 1 multiplied by x plus 3. Now you could expand this out again to see if you end up with this, and we will do that just now. 2x plus 1 x plus 3. If we expand this out, 2x multiplied by x gives me 2x squared. 2x multiplied by 3 gives me plus 6x. 1 times x gives me plus 1x. 1 times 3 gives me plus 3. If I simplify this down, 2x squared, 6x plus 1x gives me plus 7x, and then the plus 3. So we have ended up with the exact same expression we started with. So the answer is 2x plus 1 and x plus 3. And I'm confident in that because we've done this checking. What you should notice is that when I was expanding these two brackets, I ended up with the middle terms 6x and 1x, which simplified together to give me 7x, which is exactly what we did up here in splitting the 7x into 1x and 6x. So what you can see is when you factorize, when you split this middle term, it's the opposite of simplifying when you're expanding. And if you look at this from top to bottom, and here from bottom to top, you can see that we've sort of followed the opposite logic, except we skip these two steps here when we expand. But apart from that, we have all of these. We have the expression here, we have the splitting apart here, and then we have the final answer up here. So this is the method of factorizing when you have a coefficient of x squared. Okay, and finally we're on to example 7. Again, we have to factorize a quadratic with a coefficient in front of the x squared. So we're going to use the exact same method, x squared minus 8x minus 3. What we will do is we'll take the first coefficient and the last coefficient and we'll multiply them together. 3 multiplied by minus 3 gives me minus 9. I write down minus 9 onto the side and I find all the factors of minus 9, which is minus 1 and 9, 1 and minus 9, 3 and minus 3, minus 3 multiplied by 3. So now I want to find which of these pairs of factors adds up to give me minus 8, the middle coefficient. So I want to end up with minus 8, and so I add them all up. Minus 1 plus 9 gives me plus 8, 1 minus 9 gives me minus 8, so this is probably the pair of factors. I'm just going to check. 3 add minus 3 gives me 0, minus 3 add 3 gives me 0. So this is the two numbers. So I am going to take this minus 8x and split it into 1 and minus 9 as coefficients. I have plus 1x and minus 9x. And at this time I'm just going to point out that it doesn't matter which order you write them in. I could write minus 8x on the left plus 1 on the x. I will end up with the same answer. 3x squared minus 3. So now I am going to consider this half of the equation and this half of the expression by itself. 3x squared plus 1x, a common factor is x, so I'm left with 3x plus 1. Here the common factor is 3, so if I take out 3 I end up with minus 3x minus 1. But remember I told you need to end up with the exact same term, the exact same expression in both brackets here. And what you'll see is that this expression here, minus 3x minus 1, is the same as the left-hand bracket, except it has a factor of minus 1 multiplied by 3x and minus 1 multiplied by 1. So if I take out minus 3 instead, I end up with plus 3x and plus 1, which now gives me the exact same brackets on either side. So then the last step is to factorize this bracket, 3x plus 1 and 3x plus 1 from both sides. So I can write the answer as 3x plus 1, and then the remaining terms here, x and minus 3, because x multiplied by this bracket gives me that, and minus 3 multiplied by this bracket gives me this term. So the answer is 3x plus 1 in one bracket, x minus 3 in the other bracket. And you could expand these two brackets out to see if we end up with the same expression up here, but I'm confident that this is the answer.